अस्सलाम वालेकुम क्लास। टुडे इज़ आवर 17th लेक्चर और इस लेक्चर के अंदर हमने लास्ट लेक्चर में डिस्टेंस फार्मूला फाइंड आउट किया। अब इसके अंदर हम एग्जांपल्स करेंगे और उससे क्वेश्चंस रिलेटेड करेंगे। दिस इज़ ए रीइंफोर्समेंट फॉर डिस्टेंस फार्मूला। अभी आप लोगों ने डिस्टेंस फार्मूला फाइंड आउट किया और फ्रॉम ए पॉइंट टू ए प्लेन, और उसके अंदर आपके पास क्या क्या रिक्वायरमेंट है। द डिस्टेंस बिटवीन ए प्लेन विद इक्वेशन, आपको उसकी स्टैंडर्ड इक्वेशन गिवन होती है ए एक्स प्लस बी वाई प्लस सी जेड प्लस डी इक्वल्स टू 0 एंड ए पॉइंट क्यू एक्स नॉट वाई नॉट जेड नॉट which is not in the plane is given by d modulus ax naught plus by naught plus cz naught plus d mod divided by square root of a square plus b square plus c square. Now, the distance between a line in the plane from plane, obviously line की equation आपके पास क्या होगी, ax plus by plus c equals to 0, और तब आपके पास पॉइंट, आपके पास जो भी कोई आर्बिटरी पॉइंट लेंगे वो टू डायमेंशनल होगा, और q आपके पास क्या है, x नॉट y नॉट विच इज़ ऑब्वियसली नॉट on the line. Then the distance between a line in the plane is given by ax naught plus by naught plus c mod divided by square root of a square plus b square. अब आपको फाइंड आउट करना है डिस्टेंस फ्रॉम ए पॉइंट टू ए प्लेन, और इस अप्रोच को अंडरस्टैंड करने के लिए वी हैव एन एग्जांपल जो इसमें हम स्टेप बाय स्टेप आपको बताएंगे कि किस तरह आपको distance find out करना है. If the point P equals to 4 minus 4 3 is given, then we have to find out the distance from this point to the plane, and the equation of the plane, given equation of the plane is 2x minus 2y plus 5z plus 8 equals to 0. If you can see in the figure, आपके पास जो पॉइंट है वो दैट पॉइंट इज 4 माइनस 4 और 3 मीन्स के एक्स एक्सिस से उसका जो डिस्टेंस है दैट इज 4, वाई जो उसने कवर्ड किया डिस्टेंस दैट इज माइनस 4 और 3 यूनिट्स फ्रॉम द जेड एक्सिस. तो ये जो रेड कलर का पॉइंट है इज एक्चुअली रिप्रेजेंटिंग द पॉइंट P which lies outside the plane. Now you have to find out the distance from this point to the plane that is representing or showing in the figure with that you have to find out the distance from the red point to the green thumbnail. Now, moving towards its solution, we use the second formula from the page on distance from a point to a plane, which we already discussed in our first slide. From the equation for the plane, we substitute a equals to 2, b equals to minus 2, and c equals to 5, d equals to 8. And from the point, we substitute x1 equals to 4, y1 equals to minus 4, and z1 equals to 3. So that the distance from P to the plane is given by d equals to modulus 2 times 4 plus minus 2 times minus 4 plus 5 times 3 plus 8 modulus, which gives 39, and it is divided by square root 2 square plus minus 2 whole square plus 5 square, which are the direction vectors of the normal. So it is equal to 39 over square root of 33, which is approximately equals to 6.8. We have another example in which we have to find out the distance from a point to the plane, and a plane is represented in this example with the symbol phi. Is actually the smallest distance from the point to one of the infinite points on the plane. The distance corresponds to the perpendicular line from point to the plane, and the point is x naught, y naught, z naught, and the equation of the plane is given by ax by plus cz plus d equals to 0. As you all already know that the distance is given by rho from the point to the plane, phi is equal to ax naught plus by naught plus cz naught plus d mod divided by square root a square plus b square plus c square. Now we have to calculate the distance from the point, and the point which is given outside the plane is 3, 1, minus 2 to the plane phi 1. In this example we have two planes, phi 1 and phi 2. We have to find out the distance of the point from the plane 1 and from the plane 2 respectively. Phi 1 is equal to 2x plus y minus z plus 1 equals to 0, and phi 2 equals to 2y minus 3 equals to 0. Therefore, putting the values in the required formula, we have the distance from the point to the plane 1 is given by mod 2 times 3 plus 1 dot 1 minus 1 dot minus 2 plus 1 mod divided by square root 2 square plus 1 square plus minus 1 whole square. It gives 10 over square root 6. Now the distance of the point from the plane 2 is given by 2 dot 1 minus 3 mod divided by square root 0 square plus 2 square plus 0 square, which gives 1 by 2. We have another example in which we have to find out the distance of the plane whose equation is given by 3x minus 4y plus 12z equals to 3 from the origin. As we can see that the point is here is actually the origin, so its coordinates are 0, 0, 0, while from the equation of the plane we have a equals to 3, b equals to minus 4, c equals to 12, and d equals to 3. So using the distance formula from the point to the plane, we have d equals to modulus 3 times 0 plus minus 4 times 0 plus 12 times 0 minus 3 mod divided by square root of 3 square plus minus 4 square plus 12 square, and we are left with 3 over square root 169, which is equivalent to 3 divided by 13 units, which is the required distance from the point to the plane. Similarly, we have another illustration for the same topic. Find the distance d from the point, and the point which is given is minus 3, 1, 2 to the plane 2x plus 3y 6z plus 4 equals to 0. By using the distance formula from the point to the plane, we have d equals to ax naught plus by naught plus cz naught plus d mod divided by square root a square plus b square plus c square. To find the distance, we have the point with coordinate x naught equals to minus 3, y naught equals to 1, and z naught equals to 2, where the coefficients in the equation of the plane are a equals to 2, b equals to 3, c equals to minus 6, d equals to 4. So putting these values in the formula of the distance, we have ax naught plus we have 2 times modulus 2 times minus 3 plus 3 times 1 plus minus 6 times 2 plus 4 mod divided by square root 2 square plus 3 square plus minus 6 whole square, which is equivalent to minus 11 mod divided by square root of 49. We are left with 11 over 7 units, which is the required distance from the point to the plane. Now we have another example in which we have to find out the distance between the point and the plane 3x minus y plus 2z equals to 0. As we know that n with from the equation of the plane, the coefficients are 3, -1 and 2, or we can say the direction vectors are 3, -1, 2, which is normal to the given plane. To find a point in the plane, we will suppose that y equals to 0 and z equal to 0, and obtain the point by choosing x equals to 2. So the vector which is represented by b vector in our first lecture from point P to Q is given by 1 minus 2 after taking their difference between these 2 points, 1 minus 2 minus 5 minus 0 and minus 4 minus 0. We are left with -1, 5 minus 4, which is actually the same point Q. This is another way of doing the procedure. अगर हम डायरेक्ट Q point भी ले लें और उसको substitute कर दें distance formula में, तो it remains same. हम उसको भी find out कर सकते हैं, उसमें कोई ऐसा problem नहीं है. तो आप ये वाला प्रोसीजर मत करें और डायरेक्ट क्यू पॉइंट लेके और कॉफिशिएंट्स जो हैं इक्वेशन ऑफ प्लेन से लेके उनको डिस्टेंस फार्मूला में पुट करें और आप तभी आप डिस्टेंस निकाल सकते हैं. But this is another way of doing the sum. That's why I have shown it to you. After putting these values in the distance formula, the value of the line segment PQ and taking their scalar product with the normal vector and the divided by the magnitude of n, we are left with mod -3 minus 5 minus 8 mod divided by square root of 14, which is equal to 16 divided by 14, which is exactly how we find out the distance of a point from a plane. So आपकी मर्जी है कि आप जो मर्जी मेथड फॉलो कर लें. Finding the distance between a point and a line, find a distance between the point Q3 minus 1, 4 in the line given by x equals to -2 plus 3t, y equals to -2t, and z equals to 1 plus 4t. These are the parametric equations. Now the direction numbers of these from these parametric equations are 3, -2, and 4, and a direction vector for the line is given by 3, -2, 4. To find a point on the line, let t equals to 0, and from let t equals to 0 and obtain p equals to -2, 0, 1. Right, so PQ equals to 3 minus of -2, comma, -1, -0, 4, -1. The difference of the point Q and P is given by 5, -1, 3. So by taking the cross product of the line segment PQ with U, which is the direction vector, so we are left with the vector components of the vector 2, -11, and -7. By using the distance formula, we have the modulus PQ cross U divided by its magnitude. Magnitude can also be divided by the norm, so it can be replaced by norm. Which is equal to square root of 174 divided by square root of 29, which gives square root of 6, which is approximately 2.45 units. ये एक्सरसाइज है जो कि जिसमें जो सारे क्वेश्चन हैं ये रिलेट कर रहे हैं प्लेन्स के साथ, और जितना मैंने प्लेन्स का आपको टॉपिक पढ़ाया है ये सारे क्वेश्चंस जो हैं कवर करते हैं. आप इनकी प्रैक्टिस करें. और ये थॉमस एंड फिनी की बुक कैलकुलस से हैं, जो कि मैंने आपको स्टार्ट में रिकमेंडेड बुक्स में बताई थी. ठीक है.